For this problem, the key is to show the mechanism of how I got this to become this, right? So first try this on your own, and then I'll explain it after you've tried. Okay, so this is a bromination reaction, right? So the first thing you want to try is label all of your different carbons to see where bromine could attack. So bromine could attack at any of these places, right? Because there's 1', 3', and 2' all around. However, it has a preference. It prefers resonance first, but there is no resonance in the structure. Then it prefers tertiary, then secondary, then primary. So it prefers, so since we have no resonance, it's going to prefer a tertiary spot, which we have right here. So we know the bromine will attack right there. So bromination has 3 steps. It has initiation, it has propagation, and then termination. Okay? So for initiation, what happens is bromine usually pairs up with another bromine to share its one of each of its electrons to form a bond, right? So what can happen is sometimes bromine bromine is electronegative, so it can grab its electron back, and so therefore each one of these bromines will get an individual electron, right? That's why I showed it in red. It gets an individual electron, and then therefore now it becomes a bromine radical. So when it becomes a bromine radical, why it's called that is because it doesn't have a lone pair. It should have another pair right here, right? That's why it forms a bond. But since it's all on its own, it's called a radical. Now, the next step is propagation. So for propagation, one of these bromines can come and attack a hydrogen on this original compound, right? So, for example, here, right? Here we have a hydrogen here. Even though it's not shown, it's always implied. Because, for example, here we have 3 hydrogens, here we have 1 hydrogen, here we have 2 hydrogens, right? So a bromine radical can come and not attack the site, but attack that hydrogen. So the bromine can come, attack the hydrogen. So the hydrogen's electron can come and onto the hydrogen, and the carbon that was sharing the electron, its electron would go back to the carbon, right? So the carbon's electron's right there, so it becomes a carbon radical, right? And then this radical hydrogen bonds with this radical bromine. So both of them join together and then they form HBr. So it's more stable in this position, and that's why it did that. But this is now unstable, right? Because radicals are usually very unstable. So what happens is another bromine, right? Another bromine, not the same bromine, but another bromine in solution can come and see this radical on this compound, and then they can bond. And then, but once this happens, right, it's a termination step. Because after this, when this bromine pairs up with this compound, no more radicals are created. Therefore, this is a termination step. So your final compound will be this, where the bromine is attached to this main compound right here. And it doesn't matter if you put it here or here, it means the same thing, because we didn't give it a wedge or a dash. And I'm showing the each of its electrons being shared in this bond. So that's the overall mechanism for bromination. And if you just need a shortcut, because if, for example, if they didn't ask for the mechanism, they just asked, show me the product for this reaction, all you'd have to know is you didn't even have to know the mechanism. You just need to know that tertiary is the best spot, and then you just put a bromine. So that's a shortcut if you just need the product. So just find the most stable, which most stable would be resonance, but we don't have it. So next stable would be tertiary. So you find the tertiary spot, plug in a bromine, and then you'd be done. So I hope that helped, and thanks for watching.